Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai.
Welcome back, everyone. Today we're jumping into a 12th grade topic, using your arithmetic series formula. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we did today or even on homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I've been linking my 12th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is only going to have 3 parts, so leave a like, smash subscribe, and let's get started! In my previous video, we talked about the arithmetic series and we briefly mentioned what the formula would be. We didn't cover it necessarily, but we did mention it. If you missed that video, no worries, you can find it right up here. But in today's video, we're going to be jumping into the formula and showing how it helps us evaluate our arithmetic series. And today we're going to start by jumping into one of our more popular arithmetic sequences, the whole numbers from 1 to 100. And we want to start here because we want to turn this sequence into a series by first removing all of the commas and then replacing them with addition signs. Now we have an arithmetic series from 1 to 100. And if we wanted to evaluate this series, we can simply add up all the numbers. 1 plus 2 plus 3 and so forth until you get to 100, but that's the long and boring way. We can actually make this a little bit simpler by utilizing its pattern. But in order to find the pattern, you have to add this in a slightly different way. Let's look at our first term and our last term. If we add up this pair, what do we get? Well, we're going to get 101. If we add up the next pair, going in just 1 from either side, what do we get? This is also 101. If we add up the next pair, what do we get? This is also 101, and you notice the patterns here. If we're going to pair them up, starting with the extremes of our series, our first and our last term, and then moving in from both sides, 1, like we're doing here, we're going to see the same result. In this case, we're seeing 101 for each of these pairs. And this is going to continue until you get to the middlemost terms. So we see, if we want to find what this series will evaluate to, all we have to do is add up 101 how many times? Well, if we have 100 terms here, and we're pairing them up, there's only going to be 50 pairs. So we're going to add 101 50 times. If we did this, we would evaluate this entire series very simply without even having to do all of this work, 1 plus 2 plus 3 plus 4, all the way up to 100. But how do we get this right here? How do we get 101 times 50? If we were to try to make this into a formula, well, what is the 50? Where did that come from? The 50 came from our, let's write it this way, 50 came from our full number of terms, right? Our 100 divided by 2 because that's how many pairs we had. So that's where the 50 came from. How about this 101? The 101 came from adding our first term and our last term. Now, obviously you get the same thing for each of these subsequent terms, but it doesn't matter. Since it's the same, let's just use our first and our last term. So this is going to be our 1 plus 100. This is how we got our 50 times 101. Now, if we overly generalize this, we would get the following formula. Notice 100 was the number of terms, so we can say that's our n. In this case, our n was 100. And we divide our n by 2. We're multiplying by our first term, our a sub 1, and we're adding to that a sub 1, our last term, our a sub n. This is the formula for our arithmetic series if we were trying to find its sum. By simply utilizing the pattern here, we can actually deduce a formula. Here's a slightly smaller series. So let's utilize a pattern and see how it compares with simply plugging in our numbers. So we have 13 plus 23, and that's going to give us 36. And we have 15 plus 21, which once again gives us 36. and 17 and 19, which once again gives us 36. Now what's 36 plus 36 plus 36? Well, this is going to give you a 72 plus 36, and this is going to give you 108. And if we were to plug in our n and our a sub 1 and our a sub n, what will we get? Well, we get this same 108. So I'm going to put this 108 over here, and we're going to now plug in our n. We have how many terms? 6 over 2. Our first term was 13. Our last term was 23. And we know what this 13 and 23 is going to equal. That's going to be our 36. And this is going to be 3 times 36, which we just found to be 108. So you see, utilizing the pattern is the same as what we did with our formula. It's pretty easy to do it when you have a small enough series, but for really long series, you might want to just stick to your formula. But you may be asking, what happens if you have an odd number of terms in your series? Both of our series that we looked at were even. We had 100 terms. In this case, we have 6 terms. But what happens if we have an odd number of terms? Well, let's look at our next series here. So instead of having our 6 terms, this one is going to be just 5. So we have 22 plus 28 plus 34 plus 40 plus 46. Now, I always recommend to verify if it's really arithmetic, but I'm just going to tell you, because it's our example today, it's going to be an arithmetic series. However, there's only 5. So if you try to pair them up, you notice that there is only one term in our middle. So if you were to add these up, 22 plus 46, that's going to give you a 68. And then 28 plus 40, another 68. But we don't have a pair for the last term. So how does this work? Well, if we were to plug all of this into our formula, what would we get? We would have 5 over 2, our 22 plus our 46. We said that this 22 plus 46 is going to be 68. And we have 2.5 times 68. Well, this is going to give us 170. But how does that relate to this? We don't have pairs, so if we add up everything, well, remember what we were trying to do originally. Don't get lost with all the numbers. We wanted to find the sum of all this. So even if you don't have all pairs, we can still add what's left. You're just simplifying this by adding however many pairs you do have, and then you're just going to add the middle term because that's the only thing that's left over. You're still summing up everything in this series. So don't lose track of what you're trying to do. So this is just going to be 68 plus 68 plus 34. And if you were to add up 68 plus 68 plus 34, you would notice that you would get 170. Well, how does this compare to our actual formula? Well, notice, besides the end result, our 170 being the same, which should happen, we have 2 actual pairs here. 68, we found 2 pairs. And our last number, notice it's exactly half of the pair. So what that tells us is we added up 2 whole pairs and half of a pair. Notice we have 68 times 2.5 here. So it's the same thing. So it doesn't matter if you have an odd number or an even number of terms in your series, you can still utilize the formula. And if you have a small enough series, sure, just simply pair up what you can and add the middle term. It's always going to be half of your results. But how do we use our formula when we have a very long series and we don't know exactly how many terms we have? This is very easy to see. We have 5 terms, but what if we don't know how many terms? How do we still utilize our formula? Let's say we have a series like this, in which we know our first couple terms and our last term, but we don't really know what happens in the middle. This makes it hard to just use our formula. We don't know how many terms we actually have here. So how do we find our n in this case? Well, remember, this is an arithmetic series, which means that it came from an arithmetic sequence. And we have a special formula over there that can help us find our n. And if you recall, that's going to be our explicit formula. That was a sub n equals a sub 1 plus d, your common difference, times n minus 1. And we know what our a sub n, we know our a sub 1, and we know our d, but we don't really know what n is, so we can use this to solve for n. Our a sub 1 is going to be a negative 16, a sub n is going to be a negative 186, and our d is going to be a negative 10 if you see the pattern here. So this is going to be negative 10. So plugging everything in, we're going to get negative 186 equals negative 16 minus 10 times n minus 1. We can distribute the 10 or the negative 10, and we're going to get the following. Let's get this n by itself now. Now that we have our n, we can simply plug in everything else, n being 18, we can plug in everything else into our formula, and we can now evaluate this series. So if we were to do that, we would get the following. Remember, our formula is n over 2 times a sub 1 plus a sub n. Our n is 18 over 2. A sub 1 is negative 16. A sub n is a negative 186. So we're just going to minus 186. And when we do all of this, you'll notice that this whole thing is going to equal negative 1818. So even if you don't know exactly how many terms you have in your series, you can still find that by using something we knew about in our arithmetic sequence. Don't forget your arithmetic sequence. It's going to help. But let's say to give you the series in summation notation, how can we still utilize this formula to evaluate our series? Let's say we have this notation here for our series, but we still want to evaluate our series using our formula. This may look a little daunting, but this has everything that we need. So notice that this has our formula that we're going to be adding. This notation means you add this every time, substituting your k in for 1, incrementing all the way to 35 by 1. So if you were to plug in 1, that'd be your first term. Plug in 2, your second term. Plug in 3, your third term. So this is the formula for your sequence. By summing it up this way, you're going to get your series. Knowing that, we can find our a sub 1 and our a sub n. We are already given our n, which we know to be 35. We're stopping there. So we know that this is actually going to be a sub 35. So let's plug in 1 and 35 and see what we get for our terms. 1 is going to be 5 times 1 minus 2. Not all that exciting. You have your 3. And if we were to plug in, instead of 1, our 35, 5 times 35 minus 2, this is going to be 175 minus 2, which is going to be 173. So a sub 35 is going to be 173. We're using this notation to figure out what we need for our formula. Now that we have all of that, we can plug everything in. Our n, 35 over 2, and we have our 3 plus 173. We can say that this is going to be 35 over 2 times 176. And when we do that, we're going to get 3080. So even if they give you a series in this notation, no worries. Simply find what you need and then plug it into your formula. Well, I hope you were able to follow along with today's video, and I hope you now have the confidence to utilize your formula to evaluate your arithmetic series no matter how it looks. However, if you have any questions about what we saw today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.